So the atoms that elements are made from have their own structure, and they're made up of even tinier particles that we call subatomic particles. That means smaller than an atom. And these subatomic particles are known as protons, neutrons, and electrons. And every element in the periodic table is made up of a different recipe of protons, neutrons, and electrons. Every single atom of, say, sodium will have the same recipe. Every single atom of iron will have the same recipe of protons, will have the same recipe of protons, neutrons, and electrons, but the recipe for sodium is different from the recipe for iron, for example. So we're going to go into how these atoms get constructed or what they're made of. And your periodic table is going to be super important for figuring all this out. And also a lot of the activities on Mastering Biology are going to help you practice this. But there's a few things you need to learn and remember about protons, neutrons, and electrons, these subatomic particles that are used to create atoms. So first of all, where are you going to find them? Well, an atom basically has two kind of parts to it. It has a central core, which we call the nucleus. And in the nucleus of the atom, you're going to find the protons and the neutrons. So they're always found in the central core or the nucleus of the atom. And then the electrons are found kind of in orbit, zooming around the outside. So you can think of it like the center of a racetrack with the core of protons and neutrons. And then all the electrons, however many there are constantly in motion, flying around the outside of the atom. Again, that's a great simplification, but it'll work for biology. So we're going to go through some of these basic features of protons, neutrons, and electrons. First of all, let me see if I can get this to work. So first of all, these particles, protons, neutrons, and electrons, have their own unique characteristics. Firstly, we'll talk about the charge. So these are little tiny particles, and protons actually carry a charge. A single proton has a positive 1 charge. So you can think of this like electricity kind of, and positive and negative. Protons can be thought of as having, each proton is 1 positive charge. Electrons, on the other hand, have a charge of -1. So each electron has a -1 charge. And then neutrons, these particles are kind of not super exciting actually, and they don't have a charge. So we can just say no charge on a neutron. So that's the charge they carry. Protons are positively charged, electrons are negatively charged, neutrons do not have a charge. Now, mass. How big and heavy are these tiny particles? Well, relative to each other, protons have a mass of 1, and the unit we use is something called an atomic mass unit. The unit really actually isn't important. It's the only time in this class where you'll hear me say the unit isn't important. So we're going to think of protons having a unit of 1. Electrons, now these are weird particles. It's hard again to wrap your head around this, but electrons do not have, they're so tiny, they're so small, we say their mass is basically 0. They're tiny and light and we can't really measure a mass, so we're going to say they don't weigh anything. 0 mass, although they do have a charge. Neutrons, on the other hand, although they do not have a charge, they weigh the same per particle as a proton. So we're going to say they're 1 atomic mass unit per neutron. All right, so now we're building this up. Protons have a charge, positive. Electrons have a charge, negative. Neutrons, no charge. But when we think about mass or weight, protons have weight, neutrons have weight, electrons do not carry any weight. And then at the very end, on my chart here, we have the location. So let's see if we can fill that in. I seem to have lost my pen. There it is. The protons, we know, are found in the nucleus of the atom. So I'm going to write nucleus. And maybe by the end of this semester, I will have figured out how to write in here and not look like a kindergartner. So neutrons are also found in the nucleus of the atom. This is not the nucleus of a cell. It's a different type of nucleus. Get to that later on in Unit 2. Electrons are found, like we said earlier, around the outside or the edge of the atom, like in orbit. I'm going to write around the outside. So this table kind of summarizes the characteristics of protons, electrons, and neutrons. All right, so moving on, here is a little excerpt from the periodic table. I took sodium out here. So you can see the symbol for sodium is capital N lowercase a, and this is a periodic table where they give you the name as well, which is handy. And then there's two numbers you can see written in the box here with sodium. There's an 11 and there's a 23. Now, one of the reasons why the periodic table is so useful is that not only does it list out everything you need to make the entire universe, it tells you how to make atoms of all this stuff. So not only does it tell you that sodium is a building block of the universe, it says if you want to build an atom of sodium, you will need protons, neutrons, and electrons, and it's going to tell you how many of each type you need to build an atom of sodium. So how do we decipher this? Well, the lower or the smaller of the two numbers, it's not lower down, it's just the less, number 11, this is called the atomic number, and it tells you how many protons, the number of protons you need to make sodium, to make a sodium atom. Number of protons. Now, if you remember, the protons each carry a positive charge. So if we have 11 protons, we're going to have 11 positive charges. In this atom, right? And we're going to put them all in the nucleus because we know that protons live in the nucleus. So if I'm going to build a picture of sodium around here, I'm going to put 11 protons. I'm just going to write P with a plus because it's easier. And they're going to be in the central core of my atom. All right. Now, I also know, and I haven't told you this yet, but atoms do not have a charge. Overall, atoms are not electrically charged. And so if I have 11 positive things hanging out here in the nucleus of my atom, to balance out that 11 positives, I've got to have 11 negatives so that they even out and then there's overall no imbalance. So I also need to find 11 negative things to stick in my atom, and we know that the particle with a negative charge is an electron. So if I've got 11 positive protons, I have to have 11 negative electrons. And we also know that the electrons go around the outside, so I'm going to draw a big circle here to show me where the electrons are kind of go whizzing round and round and round, and there's going to be 11 electrons out here. So this number up here in our periodic table, it tells you the number of protons officially, but it also is going to be the number of electrons because the number of protons and the number of electrons have to be the same for the atom to have no charge. All right, so the only thing missing from my picture is the neutrons, and this lower number is going to give me the neutrons. So what this lower number tells you is how heavy is this atom? How heavy is this atom? It's 23 heaviness, 23 atomic mass units per atom. So looking at what I've got here, I've got 11 protons and 11 electrons. But if you remember back from the chart on the last slide, the electrons don't weigh anything. So this thing that I've drawn here so far only weighs 11 because it's got a weight of 11 from the protons and then no extra weight from the electrons. My current diagram is showing something that weighs 11. It's supposed to weigh 23. So there's some stuff missing. And what's missing are the neutrons. And so I need to add neutrons to go from 11 to make it weigh up to the 23 that it's supposed to weigh. So if I've got 11 protons in the nucleus, I'm going to have to add 12 neutrons to the nucleus. Because if I do that, 11 plus 12 gives me 23. And that's what it's supposed to weigh. So I'm going to have to write 12 neutrons. I'm just going to write an N. And that is the structure of an atom of sodium, and I was able to figure all that out from just the information in that little block in the periodic table.